Welcome back YouTube, my name is Pebs and this is the Death's Doorstep Devlog Part 7. This time I'm going to be focusing on the changes I made to the visual effects, aka the particles, as well as the sound effects that I added to the game. You'll notice there's also some music playing in the background too, as I've added a little bit of noise to the game, which was much needed and something I really wanted to add for a long time. I also added some hit animations and a death animation for the jellyfish enemy, but I'm not going to dig into that. If you recall from my previous videos, you'll remember that my particles used to be attached to the objects that they were used from. So the mummy used to have his own blood particle effect and particle system attached to this root object here. I've since changed that so I can basically share a library of visual effects. So you can see that down here in the project window. I have resources, and in resources I have a VFX folder, and there's all of these existing prefabs in here, each renamed with blood red left, blood red light. Let's inspect the blood one real quick. And here you can see this is just a simple prefab with a particle system attached to it. It doesn't have any of my own classes attached to it, aka the stitch effect class is now dead. I've just replaced it with a simple prefab with a particle system attached, and I'll show you how I use that to basically fire the effect as well as clean up after the fact. So here I have a little test scenario showing off the visual effect of when the mummy gets hit by the jellyfish. So you can see up here I have an object called game, which has my root game script attached to it. I haven't delved too much into what this does, but all you need to know is that it contains this empty game object called VFX. So if I step forward this a little bit, you'll see the hit animation happen. And actually it looks more like the jellyfish is about to get hit by the mummy based on its current trajectory. Either way, they'll show off the same result. So you can see there's a hit animation happening right, or a hit effect happening right here. And you can see the VFX object now has this spark yellow clone, which is a simple particle system. It gets created from here. You can see spark yellow is defined down here, and it was just added to this VFX and given its position in real time. It's not owned by any of these objects, it's just created as a one-off and it'll clean itself up after the fact. So let's continue that. You can see that animation finishes, and now you can see there's a couple blood blue and blood blue left and right that have appeared right there and there. And the spark yellow is almost done. It looks like it's about to delete itself, and it's gone now that I've clicked the next frame. And we can watch the rest of the animation play out, and then that's it, it's gone. The blue blood has disappeared, as well as the landing smoke puffs have appeared now that the player has bounced up and down a little bit. And that's all it really is. So I'll show you quickly how that works. So here's actually where I create the object. This is the bounce function when the player bounces off of the jellyfish object. So I make this call to game.vfx play the name of the effect that I want to play in the resources folder, as well as the position that I want it to appear. So let's actually look at this VFX service that's owned by the game object so I can show you how that all works. This is the VFX service. This is the constructor that gets called on the scene awake. And these are the helper methods to play the visual effects. So focusing on the constructor to start, we can see what happens here. So when the scene starts, we're going to load all of the files or the prefabs in the VFX folder as game objects and store them to this sorted list of effects. So resources load all VFX, and then for each one of them that we find, store them based on the object name as a game object in this list. And then we're also going to create that child VFX object within the game object, just so we have a container that we can use. This step isn't necessary, but it makes the scene view a lot easier to read. Specifically, the hierarchy view becomes a lot easier to parse during runtime. This play method here accepts a vector 2 as a position, but besides that, all it does is call the vector 3 position version of the method. So we'll skip down to that one. And then down here you can see this is where the magic happens. So we pass the name of the object we want to render, we pass the position we want to set it at. So we use GameObject.instantiate and take the effect that we stored in that sorted list by the name, the position, give it base rotation for now, and then we want to set the parent of this new object that we're creating to that container element that we created. And then we're going to grab that particle system from the object that we just instantiated, And then this is where we're going to wait asynchronously for the animation to complete. So either if the game object gets pre-abruptly deleted, or the particle system has finished, aka is not alive, we are going to destroy that game object that we created above, and then exit just ends this loop so that we don't have it running infinitely. And that's it for the visual effects. So you can see that as I'm moving around, it's creating different particles as I'm moving around and storing them in that VFX object. If I create a bunch of them all at once, they'll all show up, they'll all clean themselves up. Nice and isolated, easy to recreate for different objects. A lot better than what I had before. Now moving on to the sound effects portion of the video. Sound effects work in a very similar way to visual effects, except we don't have to wait for the particle system to finish, we have to wait for the sound audio clip to finish. So here I have another folder right alongside VFX called SFX, and if I open this up you can see there's a bunch of different folders, but they all resolve down to different audio clips. So let's take a look at these ones. So similarly to the visual effects, there is this SFX container that contains the audio clips that are currently being played. As you can see on the right side over here, there's nothing else attached to this game object aside from this audio source and the current clip that we want to play. And we are containing it nicely in this SFX object just so that it doesn't pollute the hierarchy menu here. So I can just hide this and boom, it's disappeared. So you can see as I'm moving around here, the objects are creating and deleting themselves as the audio completes. So you can see all the different sound effects as they pop up. And I'll show you how that works real quick. So the declaration of calling a sound effect is very similar to the way it was for a visual effect. So it's game.sfx.play and then the sound effect that we want to play. But you'll notice I don't actually pass the name of the sound effect like I do for the visual effect, and that is because there's some additional settings that I want to pass through here. So that SFX whip1 is actually a SFX profile struct, which has a few set parameters so I can customize the sound a little bit. I like to do this in a constants file, so you can see all the different sound effects happening here, all declared with their volumes and how much I want to step in based on the time, as well as the pitch and the pitch variation. There's lots of options and I can tweak them in a very simple manner. And here you can actually see the SFX profile struct, which basically just takes name, volume, time, pitch, and pitch variation. It's a very simple mapping just so it's easier for me to declare it all in a constants file as opposed to putting it in all my different classes. The service itself is actually very similar to the visual effects service. So in the constructor here we have another resources.loadAll call, but this time to the SFX folder. We're loading all the different audio clips and we're storing them in this clips sorted list. We are also creating a container called SFX and setting the parent of that container to the game object. And then again, we just have a simple play method here. It just takes the SFX profile options and it creates a new game object using the name of the sound effect and sets the parent to the container object. And then instead of using the prefab, we're actually adding a component this time. So we're going to add the audio source, set the clip, set the volume, set the time, and set the pitch, but randomize it a little bit. So this is where I actually use pitch variation. So every time I play a sound effect, I have this option of pitch variation where I kind of tweak the pitch randomly. So you don't play the exact same sound effect each time. It adds a little bit of variety. And then we'll play that audio source. And then very similarly to what we did with the particle system, we will loop and wait until either that audio source has vanished or it's done playing, at which point we will destroy this game object and exit this infinite loop. And that's all there is to it. If you listen carefully, you'll hear a different pitch change between the different jumps that I'm doing just now. I find it just helps to prevent a lot of rehearing the exact same audio clips, just to add a little bit more variation. So definitely give it a try if you're into that sort of stuff or into game dev in general. And that's all I really have for you this week. So next week I don't really know what I'm going to be showing you, but I'm really doubling down on making levels at this point. So hopefully I have something good to show you. Until next time, take it easy.